welcome to today's webinar in the Resident Series. It's Getting the Edge on Removables Part 2, presented by Dennis Urban, CDT, Director of Clinical Education.
Thank you, Adam. Thank you, Jessica. And good morning, everybody. It's great to be back. And today we're going to start on Part 2 of Getting the Edge on Removables. And in the first part, we talked a lot about the traditional way of doing dentures and making dentures and things like that. Today, we're really going to get into the digital side of it. So let's do a little bit of a review. Excuse me one second. Okay, let's see if my screen changes.
You don't have to get choked up, Dennis.
I always get choked up.
We're all friends here.
You get me all choked up here. Okay. Anyway, so this what we did in the first part. We reviewed. This is a little review of the first part we did, and we talked about traditional workflow and that five appointment visit with the patient, from the preliminary impression all the way to the final insertion. And we also talked about the importance of communication and case planning, you communicating with the patient and patient expectations, and the clinical protocol of what you need to do in the operatory and what we need from you at the laboratory level. And we stressed on preliminary impressions, how a good preliminary impression is going to lead to a good custom tray and a good custom tray final impression. And with that final impression, we talked about border molding, which is very important, even on the digital side, because on the digital side, you know, we did talk about intra-oral scanning, but it's still really not perfected yet with fully edentulous cases. And so what many doctors are doing are just taking the existing denture or a custom tray, they're border molding it, taking a beautiful impression, either scanning it in the office, or they sending us the STL file and sending us the STL file, or sending it to the laboratory. And we have our desktop scanner at the laboratory, and we scan the impression or the model at the laboratory. And we're able to see so much great detail on these impressions and models. And I'll show you some photos of that later on. So, and of course, we talked about the importance of occlusion. We even touched a little bit on lingualized occlusion, you know, and that's mainly for implant cases that we utilize that for. And the setting up denture teeth and the time it takes to do that, and the know-how behind that. And you'll see how setting denture teeth and how we do full arch setups in a matter of minutes with digital technology. So let's get started. And the first thing we're going to get into is printed denture technology. And there's pros really on both sides, on printed and milled. So we're going to go through that in a few minutes. So let's talk about fabricating a printed denture. Now, on the onset, I just want to let you know there are a number of systems out there that can be utilized for printed dentures, and there's a lot of good ones out there. And I don't have time to talk about all of those this morning, so we're going to talk about the Dentsply system for printed dentures, and it's called Lucitone Print. And it's you know, we've come a long way with printed dentures. If you asked me 3 or 4 years ago about printed denture technology, I would just shake my head and say, no, I don't want any part of it, because at the time it wasn't aesthetic, it attracted bacteria, the material is brittle, it didn't look natural, and it just wasn't a feasible denture, long-term denture at least. It may be a temporary one, but not a long-term. And now the materials that are coming out today, this is Dentsply, you know, there's Envision Tech, there's a lot of different companies out there who are utilizing printed technology. And we'll talk about how this has even changed in the last month or so and how it's still evolving. So let's get started. And let's look at the workflow comparison. I mentioned earlier about the traditional method, which was a 5-visit workflow or workflow in the operatory, from the preliminary impression all the way to the final insertion. And with printed digital technology, we can actually cut that down, that 5-visit workflow, to 3 visits. And in the first visit, if you take a wash impression in the existing denture and scan the impression and the bite and send it to us at the laboratory, we can get started right away on a printed try-in. So those printed try-ins are going to look a lot different from what you're used to seeing in the wax try-in. I've even had doctors trying to stick hot spatulas in the printed try-in thinking it was wax, but you can't do that. So we'll talk about how we can make adjustments with printed try-ins in a few minutes. And then if the printed try-in looks great, we can go to the third and final insertion. You can call us up, tell us, hey, listen, the patient loves the printed try-in. You can go ahead and print the denture, final denture. And what happens sometimes, the doctor will even give that patient that printed try-in to wear until the denture is done, so the denture is finished. So we'll get into some of those aspects in a little while. So again, eliminating one appointment, take a wash in the existing dentures if they're in good shape. you're probably going to have to do some border molding and take a light to medium body impression in these existing dentures. Really important. And as you can see here, you can scan the bite registration and the denture in the office. And all you have to do is just get a nice scan. As you can see here, I've got a beautiful scan here. This is wash impression. The doctor's going to send that to us in the laboratory. And when we can start designing it. And if you want us to copy that existing denture, like this existing denture, say if the patient loves the way these look, they love the inclusion, the aesthetics, we can mimic this exactly, with our technology, which is great. So if you're making a brand new denture, you pretty much have to go with the traditional flow, so you're still going to have to take a preliminary impression, custom tray final impression, bite registration, and on the 4th visit, you have that printed try-in, and then the 5th visit, the final insertion. You can eliminate one visit if you take a bite registration and custom tray impression in one visit. So what I mean by that is we'll make a custom tray type of base plate, put a wax rim on top of it, and you can border mold it, take an impression, and take a bite registration. So you can eliminate that denture that we're going to start from scratch on a brand new denture, if the patient doesn't have an existing one, to 4 visits. And we see that happening a lot. And to be honest with you, I even had a couple of doctors who actually did a 2-visit denture because they were so convinced that that patient was satisfied with that first denture, that old denture that the patient had, the existing denture, and the impression was good, the bite registration was good. The doctor just said, go ahead to a finish. So I don't recommend that. I recommend at least trying it in before we go to a completion on that. So with printed case processing, we have 4 different things we have to do. We have digitation, case design, the printed try-in, and the printed final denture. And this is the case digitation screen here. So what we do, this happens to be 3-shape, and we're going to be putting some information on the screen on this form: patient's name, order number. We're going to select what teeth are going to be replaced. Is it upper and lower denture? What type of material is going to be used? In this particular one, we're going to use the Lucitone digital print material, and we're going to have all this information, and then we're going to scan the impression or the model. So as I mentioned earlier, look at this scan on the left-hand side. Look how nice the detail is. Just beautiful. This impression and the scan impression on this was beautiful because we picked up the habular notches, all the musculature, everything we needed for a good impression, so we can move forward with a accurate denture that's going to fit well and it's going to be aesthetic. So we could see things now on the screen that we really couldn't see that well before looking at an impression or looking at a model. So this is what I love about digital technology. So we scan the final impression or the model. And I have to say, most of the times in the laboratory, we're scanning models, and the impressions work out fine, but I like scanning the models when we have it in the laboratory. And sometimes we do both. And then we pick the best scan out of all of those, which is great. So once we scanned that impression and we had a bite registration that the doctor took a bite registration, that comes back to the laboratory. That's on the 3rd visit. And then if it's going to be a new case. And then what we do, we scan the bite impression. We put this in, this happens to be the E3 scanner, digital scanner. And this is not my work right here, but this is just a traditional hinge articulator, which I'm not crazy about. In this case, what we did, we had to put little notches in the model, as you can see here. And this is going to help give us the information we need and line everything up correctly with the bite. Am I thrilled with this? Do I like to see this? No, I don't like to see this type of articulation for full upper and full lower and putting that in the 3-shape. So what I do, I have a magnetic articulator. And did I show? Yeah. So I have a magnetic articulator. I'll go back to the screen in a minute here. I put some scan spray on it. Look how nice those models are. This is a magnetic articulator. I just pulled those models off, and I'll show you what I did here. And this, all we have to do is scan that impression or those models like this. So, and then we get the exact occlusion that we need. Scan results is right on the screen here. And then we're ready to go to that virtual articulation. So everything we need is right here, but we still need that midline, cuspid line, and high lip line because all that information gets scanned into the computer and the software reads that. So it's very important to still give us that information if you're starting from scratch and taking for a new denture and taking new occlusal rims. So just keep that in mind. So The articulation with the centric and lateral adjustments with this software is fantastic because the virtual articulator allows for centric and lateral excursions, saving the dentist valuable chair time on adjustments. And one of the things I mentioned in the previous presentation was dentists and their comfort who are having difficulty getting in the comfort zone with the removables, because of all the adjustments, all the chair time, adjustments on the occlusion, adjustments on the tissue side. And a lot of this is eliminated with digital technology if it's done correctly. So the articulation with centric and lateral adjustments, you can just see it, look on the left-hand side here and see how that's going into different excursions here and how it's picking it up on the right-hand side. All those hard spots are being hit. That's going to be adjusted in the final denture, and which is great. And at this point, we're ready. If everything looks good here, we're ready to do the printed try-in. Technology is great though, but the digital articulation, the impressions are slightly digitally articulated to the bite registration using special software. And for the digital tooth setup, digital denture teeth are placed following the arch shape and bite registration. So we actually have full arch setups that come into place in a matter of seconds, and we'll show you that in a little while. And the vertical height can be adjusted in the software to open and close the bite if necessary. So say, for instance, there's an existing denture and the patient's bite has closed over the years and just needs to be opened by maybe 2 to 3 millimeters. We can do that in the software, and we can still print that denture exactly to where the aesthetics of what the denture was before, only with the bite being a little bit more open, but we can adjust the bite any way we need to, which is great. And there's that full arch setup that we can do for a full upper and full lower denture. And then when this full arch setup comes into place, we can adjust the teeth. We can adjust the size of the teeth, the angles. We can do a bold type of setup or a more feminine and softer arrangement. Whatever we need to do, we can do. So the software proposal is reasonable and can be modified using software tools. And using special software tools, every aspect of the digital wax up can be adjusted. So I don't know if you remember in the first part, I showed you my traditional characterized wax ups. Well, I would match the gingiva on a patient in a wax try-in. I would put carvings in that wax up and make it look like the finished denture. And this is a little bit different, but we can also utilize the software to put those carvings in there, put the stippling in there, and put the anatomy in there. But with the printed try-in, it's tough to get that that same characterization as I did with the traditional way of doing the setup. But we can adjust that and make it look aesthetic, and I'll show you that in a minute. So this is completed denture design. At this point, if we look, everything looks good. We can go ahead and do the printed try-in, which is fine. And we have a choice of denture too. We have a choice of 20-degree teeth, lingualized occlusion, centric occlusion, 33-degree teeth, all different kinds of teeth. And then we can now at this point, I'm not going to give it away now. I'm going to wait till I tell you till I get through this. I'm going to tell you the newest technology. Let's go through this first. So this is the printed try-in. So you can see it's very monolithic. It comes in various shades now, but we still have to check for occlusion and phonetics, and we want to make sure those aesthetics are pleasing to the patient. And this is the printed try-in in the mouth. So it looks great. It looks like good try-in. Some adjustments might have to be made, and if those adjustments have to be made, what we can do, if the midline is off, for instance, on the right-hand side, you can see here the midline is a little off. It's canted a little bit. We just take a Sharpie and mark it. If the bite is off, you can take a new bite registration. And then if it's loose in the try-in, you can actually take a wash impression. And all this gets rescanned back at the laboratory. And then that gets merged into the original case design. And we can either print a new try-in or we can go to a finish. So with this different material that's out there now with the Lucitone digital try-in material, it comes in various shades. But like you see here, it's all printed in one shade, even the gingiva part. But you can grind the posteriors down and you take a wash impression if there are fit issues, which is great. So how can we make a printed try-in look more natural? This is what got me, because I was so used to over the years making my characterized wax ups and looking really nice and making it look like the finished denture for the patient. We can do the same thing here. It's going to take a little time. We can either take some denture-based stain and stain that printed try-in. It's going to take a while though. It's going to cost more. You know, what we're trying to do here is eliminate some time and cost with digital technology. So we can do like we see here with the characterized try-in with the denture-based stain, light cured stain. But what I do, I just take some different colored waxes, and it takes probably about 2 to 3 minutes to do this. And I take these different color waxes, I really get them molten hot, and I run it across the gingiva part of the try-in. And then, you know, even though I could even stipple this in the when I'm doing the design, and it looks great. So I have a nice printed try-in with more natural look to it. So these aesthetic colored waxes that are on the market, you can utilize these waxes and just flow it around, and then you get a nice characterized printed try-in. So that everything looks good. We're ready to go ahead and for the final denture. We either get a call from the doctor sends the case back, and we're ready to print the denture. And I'll show you how we do this. So this over here, you see 5 different steps for this. So we did the scan and design already. We're going to be doing the printing now, and we're going to send that information to the printer. And then we have to put our printed material in the printer. And once that's printed, I'll go through this a little bit more in a few minutes. Once that's printed at a certain point, we take these and detach them from the printer, and we wash these off with denatured alcohol, and we clean everything off the denture. And you can see we still leave some supports. And you see that middle picture here where it says wash and recycle. Those are actually supports that are needed because the denture is not fully light cured yet, and we have to put this into a post-curing unit. So I'm going to wash and recycle this denture base, get it ready for bonding those denture teeth in. And once that's clean, ready to go, there's a couple of things we could do now with the new technology. We can either print denture teeth now, which is great. We can print full arches. We can print quadrants, or we can use existing carded teeth with specially designed for printed technology. And what I mean by that, if the traditional teeth that you take off a card, there's a carded teeth that Dentsply has. And we can, you know, and then we can loop those into the denture base and bond them into the denture base with a special material, and then we finish. And then we post cure it, and then we finish. So there's a few different ways we can do this, and this works out really well here. So this is that printed denture base material. What I like about this material is, like I mentioned earlier, a few years ago we didn't have all these different shades. You know, we didn't have all these different options with denture based colors. So we have original shades, opaque, light reddish pink, dark reddish pink, and we have all the shades really we need for great aesthetics on a printed denture base. Again, with the printer set up, we're ready to go. I sent the information to the printer, and with this particular material from Dentsply, we have to use something called a carbon printer. And so we're setting up the printer, we pour the material into the printer. And again, so we have it's printed. It's not fully cured yet, and we take these out and clean them off, remove some of the supports, not all of them, because we still have to work with these this denture and bond these denture teeth in. We wash it in the denatured alcohol, like I mentioned, and then we'll dry it off, and we're ready for the denture assembly. And like I mentioned earlier, now I don't have photos of this. Now we can actually print these denture teeth and insert them into the denture. So it really works out well. Now, using the traditional teeth, well, the 3Shape design software, it has characterization points set to indicate the position of the retromolar pads, canine points, and ridge points, and that's coupled with the use of Pound's triangle. And this allows the software to pick the mold for us, so there's no guesswork in picking the correct mold. So we don't have to go through our, through our drawer on our mold chart and try to pick the design. It's actually doing this for us now. And is it 100% right all the time? No. I've done cases, and when I looked at the design of the shape of the tooth, I said, no, I want something a little bit more ovoid. Let me go to a different selection, and you can do that. So what they have here is the IPN 3D denture teeth. They come on cards like this. And the reason why they're different for digital technology is because they cut away that ridge lap. They made them a little bit thinner, and still has the IPN characteristics, which is an interpolymer penetrating network, they call it. And it's a great tooth. Or we can print our teeth now, which is great. So, and there's the articulation key. All this information is in the computer, and it evaluates from the size of the arch and the information from the bite registration and the impression, what type of teeth that we need to utilize. That's pretty cool. It's we have all these measurements here, and we have all these teeth. Then we have all these mold choices, and they're coming out more and more molds. And the library, adding more and more to their library. So we can either use printed technology and printing those teeth or using these carded teeth. So the next thing we have to do is condition the teeth, which means that we have to get these ready so they fuse to that denture base. So the first thing we do, we put these in a warming tray, warm up these teeth with a special fluid called Fuse 1. You do that for a few minutes. And then we take another material called Fuse 2, and you can see these sockets in the denture base. They're exactly the same size as the teeth, maybe a fraction a little larger to allow for the fluid, but they seat perfectly. And what you do, you put this Fuse 2 material into each socket where the ridge lap is, place these teeth. I usually do 4 teeth at a time, light cure for a few seconds to hold them in place. And then once all the teeth are in, if you see any voids in there, like interproximally, we use a material called Fuse 3, and that just fills in all those voids. And then at this point, we're ready to final cure it and put it in the post-curing machine. And as your post-curing machine, you do this for about 22 minutes, I believe. And once this is cured, and you take off the supports, very little finishing to do, and then we're ready to polish it. So we finish and polish it, cutting off those supports, and then we have a nice printed denture. This is not my work here. This is a printed finished denture here. I'm not crazy about this denture because the posterior teeth are a little too dark for me compared to the anterior teeth, but they were just showing how you can, the denture base and how you can fit this. It just takes a few minutes just to finish and polish the denture. So there's your printed denture. And there's other technologies out there. Like I said, other companies doing this very successfully. And but this is one of the things that we're utilizing throughout the National Dentex and DSG network. And this is just a slide of how fast compared to traditional way of making a denture, which doesn't really matter too much in the operatory, but in the laboratory, it helps us with manufacturing. So some of the features and benefits, it's reduced chair time when they're printed, little to no adjustments, digital pre-occlusion, better patient acceptance with fit, aesthetics, and function, and peace of mind with the final denture outcome. And also, if anything ever goes wrong, that digital file is always available. And so if you call us up at the dental lab, hey, dentist, the patient's dog ate their denture, and that happens a lot, but the patient dropped the denture or stepped on it or whatever happens or lost it, we can print that denture in no time for you. So it takes a lot of, it doesn't take that much time at all. So we eliminate a lot of the variables, the negative variables from the analog side, and now we have the more positive variables on the printed side and digital side. And one additional thing is called the BAM factor, or BAM, body activated material. When this is put into the patient's mouth, it actually doubles the resistance to breakage because of the joules per square meter. So it goes something called joules per square meter. It increases from 1,500 to 3,100 joules per square meter, and this doubles the resistance of breakage because of the warmth of the patient's mouth. So great feature. It's a great material, and it's a great technology. So there's your printed technology, and we also use this technology for hybrid transitionals. We utilize a surgical guide as a guide when we're doing an all-on-4 and all-on-6 case, and we can actually print that denture with all the access holes already in it. And this way we don't have to spend a lot of time chairside with doing conversions. Everything's already done for you. So which is great. All you have to do is bond those temporary cylinders to the denture base, and you have your all-on-4, all-on-6, or all-on-X denture. And as you can see here, we utilize a surgical guide for this. It worked out really well. And there's the access holes with everything ready to go. Comes to you at the office, and we can still give you the chairside support that you need, but we're going to probably eliminate an hour and a half of working time there, which is great. Okay, hope everybody absorbed all that information on the printed side. Now we're going to get started on the mill denture side, which is pretty similar to what we just talked about. So let's get involved with the mill denture side now. I'm going to take a hit of caffeine here. I'm ready to go. Let me check my time. Perfect timing. Okay, good. So let's get into mill dentures. I would say on the printed side, more and more doctors are utilizing the printed technology for a less expensive denture. I don't want to say economy, but it's, you know, it's a less expensive procedure. The pucks that are provided on the milled denture side are expensive. So, you know, that's why it's a little bit more money to make, you know, and, you know, when we do our surveys, what doctors feel more comfortable with, they feel more comfortable, majority of them feel more comfortable with milled dentures, but I'll tell you, both technologies work beautiful. You know, so let's get into the milled denture aspect of it, and let's go over a simplified milled denture workflow, pretty much similar to what I showed you before. This is on a new denture. So the first appointment, we're going to take the preliminary impression, and I like to get a papillometer reading. And if you remember what I talked about in part 1 on the papillometer, I'll review it in just a minute, is when you place this special tool on the papilla of the patient, and it gives us an idea of where those anterior incisal edges are going to wind up. So if we can get that on the first appointment, then we can utilize it when we make our occlusal rims. That'll be great. So the first appointment, we're going to take preliminary impression, papillometer reading. And then the second appointment, we're going to do that base plate and occlusal rim. And when I talk about the base plate, it's a base plate where you're going to be able to take a wash impression and even border mold it. And so the reason why we ask for that papillometer reading is because it helps us contour that occlusal rim, that wax rim, a little more efficiently and a little more perfectly for you, so it eliminates a lot of your chair time of cutting waxes and adjusting and contouring. So this goes back to you for the second appointment. You're going to take a functional impression, as you can see on the left-hand side, a functional impression and a bi-registration in one visit. We'll get that back in the lab, and we're ready to go for the third visit, which is going to be a printed try-in. You're going to check for aesthetics and function, and a bi-registration on that third appointment. And on the fourth appointment, we mill it in the laboratory, ready to go. And on the fourth appointment, you can insert that final denture. So it's pretty much a 4-appointment denture if you go ahead and take an impression in the base plate and the bi-registration at the same time. If not, it's going to be a 5-appointment denture. So this is I call this a simplified milled denture workflow, because there's a more advanced one. We're not going to probably get into that today. We don't have time for it today, but you know, it's something that we can talk about at another time. But this is that papillometer reading I talked about earlier. I think I showed a little video on this last time. That little notch you see on the top picture there in the lower part, that's rests against the papilla. And you can see here, and we add about 3 or 4 millimeters to that when the patient's closed. That's going to give us an incisal edge position. So let's talk about designing and milling. So we're going to talk today about the Ivoclar system, and there's a lot of systems out there. I love the Vita Vionic system is great. We're going to talk a little bit about the Baltic denture system. I'll show you the first digital dentures that I ever made with Diamond D, and we'll go through all of that here. So let's talk about the milled denture software. So it's for full dentures and single arch dentures and immediate dentures. And the software is great, especially for immediate dentures. And we'll get into that in a little while. So I love what this software can do. And with this particular system, we're utilizing the Ivoclar Vivodent tooth library. All of you probably know the Blue Line, Vivodent, Fernaris 2, all those tooth lines are made with a special material, which really wear well. And so we have a choice of either using the carded denture teeth, as we talked about earlier, or milling these denture teeth out of a puck. And we'll go over that in a few minutes. Full arch setup function. Everything comes into play with a full up and full over, full arch setup function, and exclusive clinical tools and workflow options. And they have something called the Oversize milling process. I'm just going to touch on that in a little while. You don't really need to know that, but I'm going to touch on that in a little while also. So let's talk about the Ivoclar Vivodent, the tooth library that they have. They have Fernaris, Vivodent, and Blue Line. And all of these are great teeth. They wear well, they're aesthetic, and you have your choice. Even with milling, if you want to mill these instead of using these actual carded teeth, you can do that. And you have those full arch setups that we can utilize in designing these types of cases. Now, so the software features, this software allows for complete control to change the shape of the denture teeth. And it's important to be able to create the ideal occlusal contacts, especially for single arch dentures against natural teeth. So as you can see here, we're able to pull these teeth into occlusion. Second bicuspid, we'll bring that down into occlusion. Yeah, we can twist and turn and angle in whichever way we want. We can even make the occlusal surface wider if we need to. Great technology. So if everything's satisfactory, then we can go ahead and mill the denture. So we don't have to do a complete reset when the tooth needs to be removed, and removing molars and premolars, it's as easy as a click of a mouse. I love this feature on especially with when we're doing immediate dentures. So we want to remove one of these teeth here. So we're going to remove premolars or molar, and you see how fast this is done. We just click on it, and there you go. So we removed the premolar here, moved everything forward, and now we're able to design this further and make it a nice denture. So it's great. And this is one of my favorite features here. This is for the immediate denture aspect of it. And we do a lot of immediate dentures, make a lot of immediate dentures in the laboratory. I've made thousands and thousands over the years. And we used to do something called model surgery, which we could extract the teeth, contour the model and the tissue. So it's easy for you to insert after extractions. So this is so easy though. All we have to do now is highlight the tooth. It's gone. We highlight the tooth and it's gone. It's extracted. Now our model surgery is done on the screen for us. And then we can go and contour it like we see on the right-hand side. So any undercuts or bulbous bone, we can take that away, and we can even print you a surgical guide if you need. So really nice technology here on immediate dentures. And then there's a pre-prep scan. And this is the design for immediate dentures also, and it's utilizing the pre-prep scan and overlay function and allows us to set those denture teeth using existing teeth as a guideline. And we should do this a lot. You should use the existing teeth on many, many cases as a guideline for the final case, as you can see here. So everything comes into play nice, everything's set up for us, and then we're able to adjust if we need to, and then we're able to build the denture. So I love the ease of function with this and the contouring and the designing with this special software. And not only 3Shape has it, we have a couple of different software systems. Exocad, there's Baltic Denture System has it. So there's a lot of different systems out there that you can utilize for this design. And then the materials, we're using pucks, so it's a little bit different from the printed technology. So we have something called the Vivodent CAD for the denture base and the Vivodent CAD for denture teeth. Let me check my time here. Okay, we're good, 8:35. And this is made out of the same material that we utilize for Ivabase. It's a PMA industrially manufactured disc. It's accurate and it comes in different shades. And the physical properties are great. They're strong physical properties. It's a high impact resistance with some flexural strength, which you need. You can't have one without the other, so you need some flexural strength also. The accuracy of fit is phenomenal. Minimal deformation after milling. Some doctors don't even ask for a post-am anymore. That's how accurate it is. So the accuracy of fit is amazing with this. And it's, we talked about adjustments before. This pretty much virtually eliminates any adjustments on these types of materials. And if you want to, instead of utilizing the denture teeth on the card, you can utilize these colored discs if you want. And it comes in many, many different shades. They're very aesthetic. Matter of fact, I want to let you pick out which side. We have denture teeth on each side. I'm going to draw a line through the two centrals on each side. You tell me which one is the printed and which one is the carded teeth. Okay, I drew the line in between here. Take a look at them. See if you can tell which is printed, not printed, milled or carded. All right, so you have on the left-hand side of each one, those are the milled teeth. And on the right is the carded teeth. And when I first saw this, I picked the right-hand side as milled. So you can see how accurate and aesthetic these teeth are. It's the same material when you're milling, the same material as the teeth that are on a card. So, we have nice aesthetics. Lower opacity, the anatomical shape and emergence profile is great. And the surface design is really natural looking. Same slides here. So, and there's that full arch mill of the denture teeth. Look how nice it is. So all we have to do now is take this full arch and bond it into the denture base. And then we did the final mill and we're ready to go. So this is then they have something called the Vivodent CAD Multi. So if you want more translucency on the incisal edge and more of a natural look to it, they have this CAD Multi, which I'm going to show you in a second here. And all you have to do is we can raise or lower the puck in the software to create more translucency on the denture teeth. So it's a nice little tool. Some doctors want more, some patients want more translucency on the incisal edge, and we can do that with the software, as you can see here. Very nice feature. There we go. And then all we have to do, we have the special material similar to the material I showed you before, and we're going to bond this to the denture base. And at this point, we have a choice of, they call it oversized milling. So it's not really milled to the exact size yet in either of the teeth. And so what we're going to do is bond these in, put this back in the milling machine, and mill out the rest of the denture. And that's going to save us a lot of time in finishing. And some of the equipment that's used, this is the Premolars PM7, which is a used machine, very expensive machine that we utilize for milling these dentures. Again, the workflow is similar to what I showed you before: scan the design, print the try-in, and then milling. Now, the oversized milling process I mentioned before, we call it vestibular milling, and that's going to mill that to a certain extent. And it's not going to be final. As you can see the ridges on the top of that screen there. It's not a final mill, and either is the final mill for the denture teeth. So, but they're going to fit perfectly into this the slots or the openings in the denture base. We're going to put that back. We're going to bond it in. We're going to put that back into the milling machine and do the fine milling. And when it comes out just about finished, man. All we have to do is polish it. It's amazing. 20-minute labor time, 150-minute milling time. So it's a little bit longer than than the printed denture. Now, after all that technology I just showed you, you have a choice. There's another technology that came out from Ivoclar. It's one disc, one milling, one denture, and it's called Vivodent. And everything is put into one disc. It's called shell technology. So you have the tooth material and the denture base material in one disc, and you don't have to worry about bonding denture teeth in. So, and it's called Vivodent. So that's been working out very well. But it's choice of price and how much time you want to spend making these, but very accurate and very aesthetic. That's just the processing time. So why choose mill denture, digital denture? But again, just like the printed, accuracy of fit, bacteria resistance, great functional occlusion. Got that electronic record, fast turnaround time, fewer manual steps, and consistent quality. Then we have the uniformity of thickness and thinness. That plays a big part of this also, because a patient doesn't want that thick palatal area. It affects phonetics. So we can have that uniformity every time we make a denture, and just by designing it correctly with the software. And the monolithic strength on this, it's 8 times stronger than a traditional analog denture, which is amazing. And that's when you're milling it with the oversized technology that they're presenting here. The aesthetics are beautiful. The fit is great. I'll show you the fit right now. I can get this video up on the screen here. Here we go. So there's a full upper full lower denture that's milled. The doctor just inserted this. And you can see he's taking a lot of time. He's going to go to different excursions to make sure that the occlusion is correct. Make sure the patient doesn't trip that denture. And what do you see when he tries to take out the denture here? He's going to try. I think he takes the lower out first, but there's actually suction on the lower denture. Look at that. The fit is phenomenal. Finally gets it out right here. And check out the suction on the upper. I don't think I'll have any trouble eating any steak or anything hard with these teeth here. There we go. So the aesthetics are great, and it's a well-fitting denture. So the next technology we're going to get into, because we don't have much time here, is the Sterngold digital solution. And similar to what I just showed you with the shell geometry, where everything is in one puck, and they have this special software that they utilize for the design on this. And it's another beautiful denture material. It really is. It works out great. And same thing I showed you before with scanning the bi-registration and impression. Designing it on the screen and using a virtual articulation. So yeah,
and there's volume. There's nothing coming.
I know, that's what I think. Yeah, I didn't have the volume on. It's just I just realized that, and that's a long video, so that's why I cut it short. I didn't expect to play the video anyway. Next time we have more time, we can show that. So, But yeah, thanks, Adam. So this material is a homogeneous material too. It's, teeth and denture base are fused into one milling puck to prevent separation. And you can see how this is bonded. There's no way these teeth are going to break away from this this denture base. And this ample puck, you have small, medium, and large, different Vita shades, and you have the narrow and medium and your wide arches here. And all you have to do is pick those out, and then you can start your design. This only comes in a few shades, which I think they're expanding their shade selection with this. And it has 60 points of measurements on the intaglio surface for more accuracy and better fit. So the fit is pretty much the same that you saw with the Ivoclar denture. So this is pretty much an oversized milling here too. You see the puck going into the final, into the milling machine, doing the final mill on here. Here we go, before and after. So it's a great denture, and it's another option when you're doing digital dentures. And I wanted to show this because this was the first digital denture I ever made. So I was given this material by Keystone, and they call it Key Mill. They don't have any software. You don't utilize the software that you use for either 3Shape or ExaCAD, and you put this into the software and material database. And I milled out these dentures, and I used Vita teeth for this case here. Look how beautiful that came out. I mean, I couldn't tell the difference between a milled denture and a traditional denture. And the fit was phenomenal. And this was an actual case I did just a couple of years ago. And I think I have a picture of the upper and lower. Here's the upper and lower, as you can see here. So these are the final mill dentures with the Diamond D denture based material. So when any of these software systems, you can actually utilize other pucks with it also. This happens to be Diamond D. I talk about Diamond D a lot. This is a different type of denture based material, high flexural strength and high impact resistance. I utilize this material a lot for implant cases also. But yeah, I like to show this is my first ever digital denture, and I was proud of it because it worked out great. And it didn't take me long to learn how to utilize design. And I say that because if you have to know the science behind what you're doing. You just can't take somebody and put them in front of a computer and say, hey, make me a denture. But you really have to know the science. It takes a little while, a little bit of a learning curve to learn the software and how to design a digital denture. So this is the final mill denture here with Diamond D acrylic. So can we make a better denture? I believe we can. I mean, I think with the technology that's evolving every day on digital dentures, we're going to be there fully digital in a short period of time, where we're going to be able to scan those fully edentulous arches accurately, even with undercuts and even the retromolar pads, the hammermill notches, all those anatomical landmarks that we need to make a better denture digitally. So with that, advancements in denture technology, I hope I shared some of them with you today and you understood them. I'm excited about where we're going with technology, and just, keep in mind that, achieve the ultimate goal of patient satisfaction. And that's working with us and working with the right materials and the right communication. Well, I want to thank everybody for joining us this morning. If you have any questions, I'll be glad to answer them for you. And thank you. Appreciate it.